Okay, so welcome back, guys. Now, this video I'm releasing this video actually really quite soon after the video that I just released earlier, inverting a 2x2 matrix, and the reason being was because I was just getting really excited to introduce you guys to the identity matrix, and so that's why I decided to upload this video so soon after that video. If my previous videos haven't been even sooner than I would than normal, because I've recently been uploading quite often for that matter. Actually, on average, like 3 videos a day, and I actually started yesterday, surprisingly enough. It's incredibly exciting. I don't know. I'm just really passionate for this topic. Anyway, enough rambling about today. Like I said, I'm going to introduce you to the identity matrix, or maybe I'm not introducing you to it. You're already familiar with it. Depends on what you're studying right now. But my point is that what I want to say is that after introducing you to the identity matrix, then we will go back to this. I'll show you. We'll go back to this 2x2 inversion of a matrix. So if you didn't watch last video, I would highly recommend you to do so. So we'll go back to this, and we'll multiply this identity matrix by this alpha matrix. And theoretically, we should get the identity matrix in return, and you'll see the intuition behind why. So let's say, let's write this down. So let's just show you something you should be familiar with. If you have any number a, in this case, let's just stick to natural numbers, just to not be confusing at the moment. Any natural numbers, integers for that matter, furthermore. Stick to any integer, so a. And if you were to multiply, obviously there's a hidden 1 there. If you were to multiply a by 1 over a, in return you would receive 1. And I should have shown you this in the previous episode, because this is essentially inverting a matrix. It's multiplying by the inverse of, maybe not, but as you can see, this is if you were familiar with the identity rule within mathematics, not the matrix one, or probably countless ones, but if you multiply any number a by 1, you're guaranteed to get a back, and this is the identity rule here. And in this case, the matrix is the identity matrix is quite similar to this number 1, except in the human conventional matrix world. So if we assume that our matrix alpha was A, it's like this. Obviously, this is not how you'd classify matrices like this, but you know what? I guess we can just make up something today. And you multiply this by, let's say, 1 over alpha, and this is just purely analogous to what we've done over there. Then in return, we should get something called the identity matrix. Similarly to this, how we multiplied a by its inverse, 1 over a. So yeah, and the inverse is just, in natural number sense, is just equivalent to 1 over. It's just negative power. It's negative. It's that number to the negative first power. It's equivalent to 1 over a to the first power, which is just 1 over a. You should know this, by the way, if you're watching this. And to be honest, I am fairly young, but this is meant for older viewers to watch. Maybe viewers that are even 5 years older than I am, but anyhow, let's continue. So why don't I actually show you this mysterious identity matrix? So this works. Identity matrices are compatible for any square matrix, and again, square matrix is a matrix with the same amount of columns and rows. So if you have a 2x2 matrix, let's classify this as matrix I for identity, not to be confused with imaginary. So 2x2 is the least possible one, and that would be equal to 1, 1, and 0. So all the time, let's just make some more of these so you can get intuition and the pattern here. 1, 1, 1, 0, 0, 0, 0, 0, 0. Now if you've done Gauss, the Gauss-Jordan elimination, this should look familiar. Anyway, and finally, I'll just do one more. 4 by 4 by 4. So 1, 1, 1, 1, blah, 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 blue, blah, blue, blue, blah, blue, 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 repetitive. Okay. So now you should see the pattern. There's essentially a line of 1s in the middle and a line of 0s along the sides like this. So now that you know what the identity matrix is, and hopefully you've gained a little bit of intuition behind it, let's quickly move into, personally, in my opinion, the exciting bit. So why don't we just use the back of this? It doesn't seep through that much. You probably don't even see it seeping through, or barely. So again, let's refer back to this, where I'm going to copy both of these down, both our inverted matrix and our original matrix alpha. So this actually would be equivalent to the alpha to the negative first power, or the inverse of alpha. And by the way, in matrix notation, it's not literally 1 over that matrix. That's not really how it works. There's not much division, or there's no such thing as actual division in matrices, but that can be classified as division since, again, this is equivalent to, this here statement is equivalent to A over A, so it's analogous to division. Anyway, so I'm just going to copy these two down. So I want to multiply alpha by alpha inverse. So what would that look like? Well, it's pretty simple. It's literally what you would think. They're both 2x2, by the way. It's going to write that for grins. So this is alpha was our original matrix, right? So -8, 4, 3, 6. This is no new thing. So if you don't recognize this, then either refresh your memory or go back to the video right before this and watch it if you haven't. So now let's write down the inverse of this, supposed inverse. We're about to prove if this, to see if this actually was the inverse or not. I may or may not have tested it before the video to not embarrass myself. I guess we'll see the outcome of this. And I haven't altered anything from my past answer, just so you know. You can check back. So you guys should all be familiar with the dot product multiplication. We've gone over this quite a bit. So, but I'll just go through the process with you. So -8 multiplied by -10. Why don't we just speed through this because I'm running out of time. So -8 multiplied by -10. This is basic arithmetic. It's just positive 8 over 10, right? So 8 over 10 plus, remember, then 4 multiplied by 1 over 20. That's equal to 4 over 20, obviously. Let's simplify. Divided by 4, that's, or sorry, why don't we need a common denominator. So divide by 2, that's 2, yeah, that's 2 over 10. Okay, and so that's our first term. Now we stick to the same row and change columns here. So that's negative 8 multiplied by 1 over 15. That's negative 1 over 15. Negative 1 over 15. You can see this, right? Yep. And next, 4 multiplied by 2 over 15. That is, hold on. Oh, did you catch that? It's negative 8 over 15, my bad, right? Negative 8 multiplied by 1 over 15 is negative 8 over 15. Hopefully you guys caught that before I did. And 4 multiplied by 2 over 15 is positive 8 over 15. So you guys can start seeing the pattern if you just simplify this. You can tell this is 1, this is 0. So far it's matching our definition of our 2 by 2 matrix. We've already got 1 and 0 here. That's a good sign. Now let's switch rows and start off on the first column. 3 multiplied by negative 1 over 10. That is just negative 3 over 10. Plus 6 multiplied by 1 over 20. Let's get common denominator. So that is just 3 over 10. Oh, that's a 0 there. That's a good sign. Final term. 3 multiplied by 1 over 15. That's positive 3 over 15. Plus 6 multiplied by 2 over 15. That's 12 over 15. And there you have it. Now let's simplify. I can already tell that I've got this correct. So this simplifies to 1, right? 10 over 10 is equal to 1. In fact, we literally just went over that, funnily enough. Negative 8 over 15 plus its opposite. That's 0 all the time. And negative 3 over 10, again, plus its opposite, 0. And finally, 3 over 15 plus 12 over 15 is equal to 15 over 15, which simplifies to 1. And there you see the identity matrix. So thank you very much for watching. Hope you learned something today, and see you in the next video. Probably will upload one tomorrow. Maybe later today if I feel like it, but I think I've uploaded enough today. So hopefully you guys enjoyed. Have a nice day.